district with an experiment about light travels in a straight line from the source. Be blessed as you are listening. Materials needed: 3 cardboards of the same size, a candle for providing light, a matchbox for lighting the candle, a flat raised table, and a pen for creating holes in the cardboard. Steps follow. Step number 1. Get 3 cardboards of the same size.
Create holes in each of the cardboards.
Arrange the cardboards on the table and make sure that the holes in the cardboard are in a straight line.
Light a candle and place it behind the last cardboard.
Try to see from the cardboard which is close to you. Can you see the candle flame through the hole of the cardboard which is close to you?
Yes, I can see the candle flame.
Why are you able to see?
The holes in the cardboards are in a straight line.
If I slide one of the cardboard, do you still see the candle flame through the hole of the cardboard which is close to you?
No, I am not able to see.
Why are you not able to see?
The holes in the cardboards are not in a straight line.
What does this show? Light travels in a straight line from the source. Thank you for listening.
We are going to look at how a rainbow is formed. And how is a rainbow formed? Let us start.
A rainbow is
So we have said a rainbow is formed when light rays from the sun are disturbed by rainbow. To find out how a rainbow is formed, we need the following items: water, a mirror, and a basin. I want one person to talk about the use of a mirror.
A mirror helps us to reflect light rays from the sun to the wall through water.
That's very good. Another person to talk about the use of water.
Water helps us to act as raindrops.
Another person to talk about the use of a basin.
Basin helps us to hold water.
So we are going to see how a rainbow is formed. We pour our water in the container. Put the mirror in water. Direct the mirror to the sun to reflect light rays. Have you seen a rainbow?
Yes.
So that is how a rainbow is formed.
Allow it to Allow it to be there and we see. Slow it down.
It was prepared and designed by Teacher Chomeno Patrick, Garaya Primary School. I wish you well.
I am in primary 7 at Garaya Primary School. This is a concave lens. It is a lens which is thin in the middle and thick at the edges. It is also called a diverging lens. When a parallel beam of light strikes on it, it spreads outwards after passing through the lenses.
What type of lens is that one? Convex lens. Okay. How do we call that type of lens? Concave lens. We have two types of lenses. The first one is convex lens. The second one? Concave lens. Clap hands for yourself.
My fellow runners. My name is Nasasra Abel, a pupil of Garaya Primary School. I'm in P7 class. I have come here to explain how a convex lens works. It is thin in the middle. It is thin at the edges. When a parallel beam of light reaches the lens, when a parallel beam of light reaches the lens, it comes together at the point on the lens.
Have you understood? Yes. Clap hands for him.
Monodu Primary School. My name is Emily Bako.
My name is Muklimat. My name is Samuel Bangtu.
Our teacher gave us a project about water filtration under the theme purification of dirty water. We have a machine made out of local materials in the environment. We have the funnel and a container. In the container we have gravels and sand, and here we have a cotton, we have a jerrycan. So I'm going to pour water here to show how water can be changed clean, to show how dirty water can be changed clean. can see the water filtering. Can you see now the water, the dirty water we have changed to be clean in the jerrycan?
Yes.
So this is the method to show how we can change dirty water clean in our societies. After cleaning like this, you boil first before drinking.
Yes.
My name is Yoleka Hawa from Monabu Primary School. Our teacher gave us a project, Science in Action, Modern Sanitation, making a mean flush system model.
Yeah, I gave them a project about this system you can see here. They have come up with a model of a flush toilet system. So she's going to explain how a flush toilet works. This time, science and innovation, these students have come up with a good project for us here. So you are welcome to explain for us how this thing you have made works.
This is the water tank, and this one is the pipe. This one is the bowel seat, and inside there are waste. I am going to pour water, and the pressure will wash the feces. Are the feces there?
No.
You people, after knowing this, how flush toilet works, I think you people will become engineers and solve the problem of flush toilets in our community.
Afternoon, sir.
How are you?
We are all fine. How are you, sir?
I am also fine. You are most welcome for this afternoon's lesson. It is a lesson on disease prevention. We want to demonstrate how germs spread from one surface to another. In this experiment, we need flour, we need water. Steps to follow. Some learners are going to dust their hands in the pieces of in the chalk dust. They will in turn go and shake hands with learners who have clean hands. And those ones are going to do cleanness on their hands. Thereafter, you will have some questions to answer. I want you to follow what is going to take place. Thank you. Okay. Class, you have been seeing what is taking place. I remember telling you what we are doing is on disease prevention. Now, what did you observe? What did you observe? Yes, Winnie?
Germ spray to easy cut.
Again?
Germ spray easy to cut.
Wonderful. Let us give Winnie a clap. Thank you. Another thing you have observed? Yes.
Washing hands prevents transmission.
Thank you very much. Can we hug ourselves? Yourself with that nice answer. Thank you. That, what did he say?
Washing hands prevents transmission.
Good. So class, in this video, you can learn that washing hands prevents transmission. We can see the germs that the house flies got from the various places, the damp places, the latrines, and what have you. After flying to the hands and shaking hands, they ended up contaminating clean hands with the germs. Then thereafter, as these ones went to wash their hands, the germs which were on their hands were washed off the hands with the soap. So that tells us that germs spread easily through touch. And washing hands prevents transmission. Thank you very much for participating in this lesson. We meet again next time. But how to make a home-made water filter. Home-made water filter. One, you must be having the following: big stones, a coarse sand. Coarse sand must be clean. Then charcoal, fine sand, a piece of cloth, or you can have a cotton wool, a plastic bottle, and you also get another plastic bottle. You cut each bottom, like how you have seen, you have cut each bottom, and then you fix the mouth of this one into a plastic bottle, which is going to hold the filtrate. Then you put the fine sand, via the cut bottom of the plastic bottle. Then afterwards it is followed by what? It is followed by charcoal. This is followed by charcoal. This is followed by charcoal. Is followed by charcoal. I think the layer of charcoal can be seen there. Okay?
Divisions. We have the way how blood moves in the heart. Are we together? Yes. This is what we call the vena cava. What is it? The vena cava. It is the vena cava. Is it the biggest vein, biggest artery? What is it? Biggest vein. In the what? In the heart. This is the biggest vein, the main one. All veins transport the oxygenated blood. But apart from which one? From the vein. Exactly. So, the blood. Now this is this side which has blue. It is deoxygenated. Blood is coming from the vena cava. Has picked blood from all the body parts. To pass through it. After picking it, that blood will come here. Are we together? To the right auricle. When it reaches here, what will happen to that blood? That blood has to diffuse that carbon dioxide. That means it has to pass through many processes to get oxygen. That blood will come here through the valves here. How do we call this part, this division? The right ventricle. This blood will come. When it reaches here, it will go to this vein. Which vein is this? This is the pulmonary artery. This artery transports the oxygenated blood to where? To the lungs. Exactly. It is taking it to the lungs to do what? To get oxygen and diffuse carbon dioxide. Exactly. So when this blood reaches here, now it has gone to the lungs. After some process, that blood will be taken, the one that has gained oxygen, will be taken to the pulmonary vein. Because all veins transport the oxygen apart from the pulmonary vein, it transports oxygenated blood. So when that blood diffuses carbon dioxide and gains oxygen, it will be taken to the pulmonary vein. This pulmonary vein, we'll bring it here. Which division is this? This division? Exactly. Because it is upper, this is the left, this is the right. So that blood will pass through this valve. Are we together? It is already oxygenated. It will come. This division? Left ventricle. Exactly. It will come to pass through this going to the aorta, the biggest and the main artery in the body. It is the aorta. When it passes through to go to the aorta, when it passes through the aortic valve, because this is the aorta, it will come directly to the aorta. Now, upper the aorta, we have the head. Are we together? Yes. Then the aorta will take it to the brain. Then the brain will tell the aorta, take to the body parts, take there, take here, take here. That aorta transports oxygenated blood to all body parts in the body. All of them, it is the aorta that does that. Aorta. Not this vena cava. The vena cava picks the oxygenated from all the body parts. Then this aorta transports oxygenated to all. The other is picking, this one is it serving to all the body parts. Then after serving to all body parts, you start moving, you run, you play, you do what?
My name is Among Lilian. I'm not in primary 6th class at St. Tipo Day and Boarding Primary School. The head teacher is Mr. Selmaga Robert. We have projects in our class. These are the projects: waste management and crop growing. We start our project by collecting all kinds of rubbish from our school compound, and then we take to the main collection center for separation. Now we are in the main collection center. We are separating materials which do not decompose, and we put in the sack for recycling and to reuse them, and we leave which decompose to form soil for us to use in the project of crop growing. We get that from the soil and we put in 2 sacks in which we are going to plant our seedlings, and we form the smart backyard gardens as you see. make our crops grow well, we weed them and move all rubbish which are in the garden, and we take back to the main collection center for decomposition. Adopting the idea of the smart backyard gardens, the school has been able to provide us with vegetables, which has improved on our diet. Pupils have also taken this idea at home, which has made their parents happy because it has also improved on their diet at home. I remain among Olian. I'm not from St. Paul Day and Boarding Primary School, Chitagoba. What man has done, man can do. It's our motto. Bye.
In this practical experiment, we are going to find how salt affects density and buoyancy. Class, define density.
Density is the measure of how much mass is contained in a given volume.
What is buoyancy?
Buoyancy is the upward force exerted by a fluid that opposes the weight of an immersed object.
Why does an object float on fresh water?
An object floats on fresh water because its density is less than that of water.
Why does an object sink in fresh water?
An object sinks in fresh water because its density is greater than that of water.
Okay, now let us do this practically. We are going to have 2 glasses, water, salt, 2 fresh eggs and a spoon. This glass of water doesn't contain salt. Now this one, I'm going to put 2 spoons of salt. Does this glass contain salt?
No.
Let us put this egg and we see whether it thinks or floats. And this one contains salt water. Why does an egg float on salt water?
An egg floats on salt water because adding salt increases the density of water, making it denser than the egg, which causes the egg to float.
Why does an egg sink in fresh water?
An egg sinks in fresh water because its density is greater than that of water.
So, this is how salt affects density and buoyancy.
Okay, members, I was saying, members, can you pay attention please?
Yes.
I was saying that we have been able to use a separating funnel to separate cooking oil to separate water from cooking oil. And we have seen the reason as to why it is very possible to separate these 2 liquids using a separating funnel. And someone told us the reason as to why is because cooking oil and water, they have different densities. So cooking oil has less density compared to water, meaning water has a higher density. It is more dense than cooking oil. However, a separating funnel can only help us to separate mixtures of liquids which have different densities. Altogether, if you are given, or when you get a scenario where you have a mixture of two liquids which have relatively the same densities. For example, if you have paraffin and petrol, those liquids they have relatively the same densities. So what you do, you look for another suitable method. Members, and which method is that one? Which we can use by show of hands. Which method can we use to separate mixtures, liquid mixtures of different densities? Sorry, to separate liquid mixtures of relatively the same densities. By show of hands. Yes, Sheila?
Fractional distillation.
Speak louder.
Fractional distillation.
Yeah, we use what we call
fractional distillation.
And what helps us, which scientific fact can help us to use fractional distillation to separate liquid mixtures which have relatively the same densities? Why is it able? If you are asked the question, why is it able to separate mixtures of relatively the same densities using a fractional distillation? What helps us, or how are we able to separate mixtures of relatively the same densities using a fractional distillation? How are we able to separate them? Class, how are we able to separate mixtures, liquid mixtures of relatively the same densities using a fractional distillation? Yes, Nakawes.
They have different boiling points.
You speak louder.
They have different boiling points.
Exactly. Members, clap hands. Yeah. So those liquid mixtures, we use a fractional distillation to separate them, and what helps us, or what enables us to separate them using that method is their boiling points. Now they have different boiling points. Out together.
Yes.
Yeah. Thank you so much. Any question about fractional distillation? Sorry, I mean any question about separating liquid mixtures using a separating funnel? No. Okay. If no question, I wish you a good day. Thank you so much for listening. May God bless you.
So we first wait for these liquids to settle, because we shall wait for the water to go down, because this cooking oil is less dense than water. Now give some time for these mix these two mixtures to separate. If I am to ask Rambali on these two liquids, which one is going to be on the bottom and which one is going to be on the top?
Water is going to be on the bottom,
yes,
and cooking oil is going to be on the top.
Yes.
Oh, good. Maybe, excuse me, can you give us a reason as to why cooking oil remains on top and then water goes down to the bottom?
Water is more dense than the cooking oil.
You may continue.
Now, in some future minutes, there are some properties of air which is going to be being shown. I'm going to show you in future minutes to come. Let's now first wait in a few minutes to come. Some minutes to come.
Where is our stand?
I think now it is ready.
It's not yet.
On my eyes to watch.
Okay. So I think the liquids have already separated. Okay.
Yes.
I think we can now.
I have an idea.
Now,
Open.
Here, I want to show you something which I have observed. When we remove this, so what is it called? First wait.
A volunteer to head up Wambale.
As we see, this is the property of air. Ramba, if you were to give me which property of air is this one? Because if we are to observe it very well,
Just a point.
Air is better.
give a reason to support your answer.
My friend, your reason.
Change when I'm asking you who is shouting. Can you tell me the property of air you are observing from here? Change, please. Stand up. What? Can you give a reason to support your answer? Change, please.
Okay, let's come back here.
Now we will open this upper part. As we are observing, now we can observe water.
Yeah, so members is trying to show us that what we have got out is completely
water.
Can we say? Yeah. So it is completely water, and we have now remained with our cooking. We have now remained with our cooking oil out together. Yeah. Remember.
Yes, sir.
Remember our question was.
Yes.
Can we read the question?
Why is it
Good evening, class.
Good evening, sir.
How are you today?
We are humble and obedient.
Yes. Who can read for us the question? Yes, Sheila, what was our question?
Why is a maize plant not able to carry out self-pollination?
Can we repeat?
Why is a maize plant not able to carry out self-pollination?
Yes, members, using our plants of maize that we have here, who can come and explain the reason as to why a maize plant can't carry out self-pollination using our maize plants that we have here? Yes, Happy.
Good evening, class.
Good evening, Namuga Happy.
I'm by the name of Namuga Happy, and I'm going to explain why a maize plant cannot carry out self-pollination using our maize plant over here. So the reason as to why maize plant cannot carry out self-pollination is simply because the male part and the female part are far apart. So let's say this is the pollen grain. Let's say if it falls, it's likely to be carried away by wind or maybe obstructed by the leaves. So that is the reason why maize plant cannot carry out self-pollination. Thank you for listening.
Yeah, thank you so much, Happy. As she has said, maize is one of the common crops that we grow in our areas, but its way of flowering is a bit different from the way other plants carry out the flowering. And the difference is that, as she has said, is that the middle part of the flower, that which is the stigma, the middle part of the flower, okay, the one which produces the pollen grains, which are the anther heads, are far apart from the female part. So it means if this plant is to entirely based on pollen grains that are produced by itself, then it means there are higher chances of the female part, which is the stigma, to lose or to fail to have or to receive the pollen grains produced by its anther heads. And that can easily be due to wind that blows away the pollen, since the pollen produced by a maize plant is light and can easily be carried by wind. So that is why it stands other chances of receiving pollination from other plants nearby, so that pollination can take place in order for fertilization to occur. That is why in most cases you find that when you have a maize plant garden, and maybe your neighbor also has a maize plant garden, and maybe of different types, you'll find that, for example, if maybe your neighbor grew corns, the brown in color, and for you have a garden of maize which is white, ordinarily white in color, you find that during that process of pollination, you'll find that pollen grains from your neighbor's garden can easily be carried to your garden, and getting maize of different colors within your garden due to cross pollination that takes place during that process. Okay? Yes. Thank you so much.
We are going
questions while the water is boiling. Mention the natural process represented by the above experiments. Semaphore. Clap for him. Set the role of the part marked M in the experiment. Part A. This is part M. We have a charcoal stone. Now you tell us the role. It makes the water boil. Clap for him. What does part Z represent in the environment? This is part Z. Letitia. Clap for Letitia. Name the physical process taking place at point marked W.
Where is the point?
W, it is this. Myoma. Condensation. Clap for him. What does
Hakushika rekodi nje.
Now let us cut this metallic cover.
Which process is moving? Are you seeing rain starting to come?
Yes, the droplets.
Are you seeing the droplets?
Yes.
Rain is raining now in Nanyang. It's raining where? In B6 is raining.
Members, what does the metallic cover represent? Otieno?
Represents what?
Clouds.
Good. The materials.
Yeah, over 5.
What about the water bodies, the water in the kettle? Never.
When you close that, you can start another one.